So we were looking at the limit as x approaches 0 from the right of 1 over x minus 1 over our tan of x. And first of all, we noted that we had an indeterminate form of type infinity minus infinity. So we had to transform it into a quotient of type 0 over 0 or infinity over infinity. So taking the least common denominator and combining, subtracting, we get limit as x approaches 0 from the right of arctan of x minus x all over x times arctan of x. And now we notice that if we were to plug in 0, we would have a limit of the type 0 over 0. Notice I did not say equals 0 over 0, because that's impossible. All right, so now we can use L'Hopital's rule. So using L'Hopital's rule, we get the limit as x approaches 0 from the right of the derivative of the top, which is 1 over 1 plus x squared minus 1, over the derivative of the denominator. Well, we have to use the product rule here. So it's the first times the derivative of the second plus the second times the derivative of the first. Now let's clean this up so we can look at it. It's a compound or complex fraction, whatever those are called. So let's get rid of the fractions that are within the fraction by multiplying the top and the bottom by the LCD of all the fractions. And so that would be just 1 plus x squared. So multiply the top by 1 plus x squared, and then the entire denominator by 1 plus x squared. And after we distribute that, we get the limit as x approaches 0 from the right of 1 minus 1 plus x squared over x plus 1 plus x squared times the arctan of x. And it looks like I can clean up the numerator a tiny bit, so let's call this limit x approaches 0 from the right of just negative x squared over x plus 1 plus x squared times arctan of x. All right, now if we want to try to plug in 0 again, it turns out we have another 0 over 0 indeterminate form. That's okay, we can use L'Hopital's rule on that. So let's do it. So we get the limit as x approaches 0 from the right of negative 2x over 1 plus, and now I got to use the product rule. It's the first times the derivative of the second plus the second times the derivative of the first. Let's clean that up a little bit. So we get the limit, x approaches 0 from the right, negative 2x over 1 plus 1 plus arctan of x times 2x. And now let's see if we can plug in 0. If we plug in 0 on the top, we get 0. In the bottom, we get 2 plus 0. So this works. So we can say this limit is equal to 0 over 2, or just 0. And that's it. So we had to do L'Hopital's rule twice, but first we had to put it into a proper quotient of the proper indeterminate type. And then we had a lot of algebra to do. All right, have fun. And I'll see you in the next video.